Today we're going to be taking some time to go over some of the concepts dealing with rational functions. Some of you have seen this before, but we're doing a review. We're going to be covering things like vertical asymptotes, horizontal asymptotes, slant asymptotes. We'll probably not get to slant asymptotes until tomorrow, but I do want you guys to start out with this parent function right here. A rational function is basically when you have x values not just in the numerator but also in the denominator. So this is the parent function for all rational functions. Okay? So let's go ahead and type that into our graphing calculator and see what it looks like. Get y equals. I'm going to clear this out. Do alpha y equals enter. And do 1 over x. Okay? And I want you to hit the zoom forward button and kind of take a look at it. Okay? So basically what we have here is we have y equals 1 over x. In function notation, that would be f of x equals 1 over x. Okay? Now, there's a certain number that you are not allowed to have in the denominator. And what number are we not allowed to have in the denominator? 0, right? Because you can never divide something into nothing. All right? It's impossible. So, right here, you would say, right here, that we could not have x equal to 0. We actually, right there, just found what's known as a vertical asymptote. We have a vertical asymptote where x is equal to 0. So, in your journal, make an x-axis right here, all right, and there's your y-axis. And I want you to actually, if you can, if you have twistables, great. If you have a highlighter, great. We're going to draw in an asymptote right here going all the way up and all the way down. It's kind of hard to see, so I'll make it a little bit thicker. So we have a vertical asymptote going all the way up and down at x equals 0. That's what this means. Remember, all vertical lines are x equals. Okay? Now, anytime you guys can make a denominator in a rational function equal to a 0, what are you going to have? You're going to have a vertical asymptote at that particular place. We'll do some more examples here in just a second. Now, in this graph, we also have what's known as a horizontal asymptote. All right, I'm going to change the color here. We actually have a horizontal asymptote right here on the x-axis. We do. By the way, a horizontal asymptote and a vertical asymptote. What are asymptotes? They're basically boundaries. All right? Where the graph, now sometimes, in some cases, the graph does cross them, okay? For this particular case, you'll notice that this graph going here and this graph going here, they get close to the asymptote, but they actually never cross over the asymptote. All right? So the asymptotes are boundaries that is in a graph that it's not going to cross over most of the time. Like I said, we're not going to probably get to certain ones today where it would cross over. So right here, this is referred to that your horizontal asymptote is at y equals 0 in the parent function. Okay. Now we're going to go over the rules for horizontal asymptotes later. Okay? Because there are rules. Sometimes your horizontal asymptotes are not going to be at 0. Sometimes they're going to be above or below the x-axis. Sometimes you're not going to have them at all. We'll go over that in a bit. But right now, I want us to focus on how do you find vertical asymptotes. Okay? So what I want us to do now, you guys have a good little picture there. All right, horizontal asymptote, vertical asymptote. Once you go to your y equals, and in the denominator, right here, we're going to keep everything the same, except down here, I want you to go plus 3. And then hit the graph button and see what it looks like.
Zoom forward.
Yeah, zoom forward is fine. Okay, interesting. So our new graph is y equals, or f of x equals 1 over x plus 3. So what would be a bad number to plug in right here for x? Negative 3. That would be bad, because what would happen to the denominator? We'd make it equal to a 0. So interesting, look what happens right here at a, look what happens to the graph at negative 3. Right here, at a negative 3, what was created?
Vertical asymptote.
A vertical asymptote. It's like you get to math cuts and you don't even get in trouble with that. It's awesome. Just don't hold the first syllable too long. Alright, otherwise you might get in trouble. Alright? Well, last time when I was telling you about the word, you held that first syllable just a little bit.
Tyler.
Oh, I was Tyler, but I'm sorry, you switched seats. You're right. It was Tyler. I apologize.
Okay.
Alright. So, over here, our vertical asymptote is where? It's at actually x equals negative 3. Okay? You're going to be called upon to locate and draw vertical asymptotes in the assignment. So right now we're practicing doing what? We're practicing drawing and locating. Okay, now we're going to change something in the graph. Go to the denominator right here. So you're going to go in the denominator next to the x. I want you guys to go open parentheses. Type in x plus 3, close parentheses, open parentheses, x minus 2, close parentheses. So right now, I want you guys to put this right here exactly as it appears. Make sure you don't put a negative sign. Make sure you guys use the minus sign between the x and the 2. Okay, because then you would multiply. If you did the negative sign, it would be think that you're multiplying. Okay, hold on. We're just doing one at a time. Once you have it, go and hit graph, and let's take a look at this one. Okay? Now, that's kind of sad. Alright? Now, what I want you guys to understand, right here at a negative 3, do we still have an asymptote? We still have a vertical asymptote at a negative 3, but right over here at a positive 2, we also have a vertical asymptote. So what I want you guys to do is this graph, I want you to, you're going to draw 2 vertical asymptotes. And I'm just going to continue the graph. Technically, the graph would keep going up here, and down. So we have right here at x is a negative 3. And right here where x is equal to a positive 2, we have 2 vertical asymptotes. Now, something I didn't mention is we still technically have a horizontal asymptote right here at y equals 0. Okay? So the horizontal asymptote is still at y equals 0 on both of those graphs. So I didn't draw it in the other one, but there's still technically a horizontal asymptote right here and right there. But like I said, we're focusing on the rules for vertical asymptote. So I'm going to draw the equation here. We have f of x, or y, equals 1 over x plus 3 and x minus 2. And it looks like there's 2 places. All right? There's 2 places where you could plug in numbers that would make the denominator equal to 0. X could equal a negative 3, or x could equal a positive 2. And that's what creates those vertical asymptotes in the graph. Okay?
They're just opposite.
Well, for example, if I plugged it in, here's what it would be. Ready? If you plug in a negative 3, it would be negative 3 plus 3, and that would make this equal to 0, and any number times 0 is 0. All right? So even though this would be 3 minus 2, even though that would be a 1, this would be 0, and 1 times 0 is 0. The other number you could plug in was a 2, and that would make this part equal to a 0, which would, if multiplied to everything, would make that whole denominator equal to 0, which would be bad. It's like in Ghostbusters when they said, "Don't cross the stream," right? Why? They can do that. All right. So right now, what I want to test you guys on.
Was that a question or?
That was it. Right now, I'm going to test you guys. Right now, in your journal, I want you guys to write this equation down. Don't graph it, just write it down.
Is this a new problem?
Yep. Okay. So there is just an example problem right here you're doing in your journal. I want you to name all vertical asymptotes. Okay? So see if you can name all of them. If you're watching the video, you can pause it, see if you can name them, and then restart. All right, so we have 1, 2, 3, and 4, technically 4 vertical asymptotes. Does somebody want to give me just, not all 4, but just one of them they feel?
-5.
-5 in your voice. -5, yes, right here, if I plug in a -5, that would make that whole denominator equal to 0. Changing colors. What's another one?
4, sir.
You already gave an answer. 4. Right here, because 4 minus 4 makes that whole thing equal to 0.
1.
1 is correct. I'll change colors. 1. Right there. And last but not least, what number could you plug in there that if it multiplied to everything would make it equal to 0? 0. So we would have 1, 2, 3, 4 vertical asymptotes in this graph. This graph would look crazy. You guys want to see what it looks like? Just see what it looks like. All right? Just for fun. All right, this is not fun. I know fun. This is not it. All right, so let's go here. I'm just clear this out. Hit alpha, y equals, enter. I'm going to go down here. Oh, put a 1 there. Go down here and put x plus 5. Not x 5. X plus 5 in parentheses. Then I have what? X minus 4. X minus 4 in parentheses. Open parentheses. X minus 1. And then I just had an X just sitting there at the end. Then I make a graph.
That's weird.
Alright, now, understand. Alright, I'm going to zoom 6. See if it seems any better. Okay, you're able to see it, see the axis. You can kind of see how it continues on. But let me kind of finish the drawing here, all right? So it's kind of hard to see, all right? So I'm going to draw them in real quick. Make it a little bit thinner though. So right here, we have an asymptote right there at 0. We have an asymptote right here at a 1. We have an asymptote right here at a 4. And right over here, we have a vertical asymptote at -5. Okay? And so it's kind of hard to see what's happening in the graph, all right? Because it doesn't continue, but that's where all those vertical asymptotes would be located. Okay. All right, so we finished with vertical asymptotes. Now we're going to be going on to another concept.